Welcome, dear chemistry learners. Unit number 2, Fuel and Combustion. Let us start lecture number 4. What you are going to learn in today's lecture: solid fuels, types of coal, analysis of coal, proximate analysis, ultimate analysis. Let us start with the solid fuels. As we know, fuels are have three types: solid, liquid and gaseous. Out of that, the solid fuel and the most important solid fuel is a coal. We know the coal, which on burning produces the large amount of heat. Coal is a highly carbonous matter formed from vegetable matter buried in geomorphic changes under pressure by the action of aerobic and anaerobic bacteria for a long time. What is by coalification? The process of conversion of wood into coal is known as a coalification. So once the wood is started to convert into coal, this process is known as a coalification. It is not the direct procedure. There are some formations are in between. Let us check. First, when the wood on heating, it is converted into peat. Then peat coal is converted into lignite coal, which on heating convert into the bituminous coal, and lastly bituminous coal on heating convert into the anthracite coal. Now look at here, the transformation of wood to peat, peat to lignite, lignite to bituminous and bituminous to anthracite. Every time the percentage of carbon increases, means the percentage of unwanted material present in a wood decreases, and hence we can say that anthracite is the purest form of the coal, and this process from wood to coal is known as a coalification. Now look at here, this is a peat coal, lignite coal, bituminous and anthracite, called as a hard coal, and peat coal is not actually a coal. So increasing the moisture content, here increasing the heat and carbon content. So more is the percentage of carbon, pure is the coal. How to analyze the percentage of the coal in coal sample? Now there are two process. One is the proximate analysis, second is the ultimate analysis. First, proximate analysis. It is nothing but the study of analysis of coal sample, in which first moisture percentage, second volatile matter percentage, third ash percentage, and lastly the fixed carbon percentage is determined. So when we determine these 4%, this analysis is known as a proximate analysis. Let us start the first, moisture percentage. Formula for moisture percentage is equal to moisture percentage formula, moisture percentage is equal to loss in weight upon weight of coal sample into 100, that is m minus m1 upon m into 100. So whatever the loss in weight, so what we have to do, first we have to take a coal sample and we have to weigh it. Then after weighing that coal sample, we have to heat that coal sample for around 110 degrees Celsius. So whatever the moisture will be there, that will be removed. Then whatever the loss in weight upon weight of coal sample into 100 is nothing but the percentage of moisture. Second, how to calculate the volatile matter? Now the same coal sample, after measuring for the moisture, that we have to keep into a muffle furnace for 7 minutes only, and that is for around now around 100 700 to something degrees Celsius, 725 degrees Celsius, then again the weight will be loss, and the weight of the volatile matter, that is loss in weight upon weight of coal sample taken into 100, is nothing but the volatile matter percentage. Third is the ash percentage. Now how to calculate the ash percentage? After calculating the volatile matter percentage, the coal sample is kept in a muffle furnace for half an hour to around 700 to 800 degrees Celsius, and the whatever carbon is present in that coal sample, that totally burnt, and what remain as it is, that is the ash. So weight of that ash upon weight of coal sample taken into 100, we can get the percentage of ash. And lastly, fixed carbon percentage. 100 minus the percentage of all these three, that is percentage of moisture, volatile matter, and percentage of ash, is nothing but the fixed carbon percentage of that coal sample. Next is ultimate analysis of coal. Definition: the analysis of coal in which the percentage of carbon, hydrogen, nitrogen, sulfur and oxygen elements are found out, it is known as a ultimate analysis. First, determination of the carbon and hydrogen. Now look at here. This is the combustion chamber in which a porcelain boat is taken and the substance, that is a coal sample, is taken, known amount of that. So pure dry oxygen is transferred from this side, so easily the combustion will take place. Now in this furnace, when we burn the coal sample, if it contains a carbon, it is converted into CO2 due to the oxygen, and if it contains the hydrogen, obviously it is converted to H2O. So to this furnace end, two U-shaped tubes are attached. This first U-shaped tube is filled with the anhydrous calcium chloride, which is having a characteristic or property to capture the moisture present in the atmosphere. Or for example, if H2O is present in this furnace, that will captured by this anhydrous calcium chloride. And this second U-shaped tube contains the KOH, which having a property to capture the CO2. So if carbon is present, that will convert into CO2 and that will captured by the KOH. If hydrogen is present, that will convert into H2O and it will captured by the anhydrous CaCl2. These two U-shaped tubes are filled, and then we know the amount of calcium chloride and KOH. So if when we burn the that substance, CO2 is captured by this KOH, the weight of KOH tube increases. Similarly, by capturing the hydrogen in the form of H2O, anhydrous CaCl2, weight increases. Increase in weight of these two tube is nothing but the percentage of carbon and hydrogen. How to calculate that? So percentage of carbon is equal to weight of CO2 form. Means weight of CO2 form means the weight of KOH increases is nothing but the weight of CO2 form into 12 into 100 upon weight of coal sample taken into 44. How to calculate the percentage of hydrogen? Weight of H2O form means the weight of anhydrous CaCl2 increases is nothing but the weight of H2O form into 2 into 100 upon weight of coal sample into 18. So by using these two, we can easily calculate the carbon and hydrogen percentage. Next is sulfur. It is equal to weight of BaSO4 form into 32 into 100 upon weight of coal sample into 233. Nitrogen is nothing but volume of acid consumed into a normality of NaOH into 1.4 upon weight of coal sample taken. And lastly, the percentage of oxygen, which is equal to 100 minus percentage of carbon, hydrogen, sulfur, nitrogen and ash percentage, that we already seen in a proximate analysis. So what you learned from this today's lecture: solid fuel, types of coal, analysis of coal, that is proximate and ultimate, analysis. Thank you.